I'm Anil Kumar. Welcome to my series on calculus, global learning. We are sharing with you a question from Trinity College, which is being shared by one of our subscribers. Let me thank all the viewers and subscribers for watching my videos and sharing such brilliant questions. Question number 5 here is, determine the exact shaded area between the two functions f of x equals to sine x and g of x equals to 3 square root 3 over 4 pi x. We are given the points of intersection, so we don't really have to work out these points. So one of them is 0, the other point is 2 pi by 3 with a y value square root 3 over 2. I'd like you to pause the video, answer the question, and then look into my suggestions. So clearly the sine curve is the curve which is there on the top. So we'll write this as f of x, and the straight line is g of x, correct? And those are the point of intersection. So when we want to find the area under the curve, we can calculate the definite integrals, correct? So basically, we would like to find the area under the curve as the value of integral from 0 to this point, which is 2 pi by 3, right? 0 to 2 pi by 3. Now, since the function f of x is above g of x, we could write this as f of x minus g of x, correct? So that is what will be the integral, right? Okay. So we are given what f of x is, which is sine x. So let me rewrite this as integral 0 to 2 pi by 3. And here we have sine x minus g of x is 3 square root 3 over 4 pi x dx, correct? So that should give us the solution. Integral for sine x is minus cos x, so we could write this as from 0 to 2 pi by 3 minus cos x, and that will be x squared by 2, right? So we get this as minus 3 square root 3 over 4 pi times x squared by 2, correct? So that is what, so we actually wrote the integral. So let me write this as from 0 to 2 pi by 3, correct? Okay, so that is what our answer is going to be. We need to now evaluate the value. So we'll just plug in 2 pi by 3 here and then find the solution. So what we get here is equal to, let's first put 2 pi by 3. So we have minus cos 2 pi by 3 minus, okay, let's simplify this if we can. It is 8, that's okay. So we'll write this as 3 square root 3 over, we can write this as 8 pi, okay, x square, which is 2 pi by 3 whole square, clear? So that is this value, okay, minus, now plug in 0 here, so we get, when you plug in 0 here, we get minus cos of 0 degrees minus, and when you plug in 0, you get 0 here, okay. So that's what you get. So cos 2 pi by 3. So you can look into the, see, the calculator is not allowed for this test paper, right? So cos 2 pi by 3 really means that we are working in the second quadrant, right? So that is the angle. And 2 pi by 3 will give us acute angle of pi by 3, right? So this is 2 pi by 3. So for pi by 3, if I sketch the triangle, then the cosine value for pi by 3, it is 1 over 2, correct? Okay. So we could write this, and we are in quadrant 2, that means it is negative, perfect? So it is negative. So let me write down here, the value here will be equal to negative of negative half, right? So cos pi by 3 is half, and cos 2 pi by 3 is going to be minus half, correct? You are in quadrant 2. Okay, so this is minus half for us. And here we have, when you plug in 2 pi by 3, we get this as minus 3 square root 3 over 8 pi, and that is 4 pi square over 3 square is 9, right? Okay, and minus, we get here minus 1, right? So minus, of course, 0, which is minus 1. Let's put this in brackets. Okay. So that's what we have, right? Okay. So now minus of minus half is basically plus half, correct? And here we have 3. You can simplify this a bit. Dividing this by 2, pi also goes, and 3 goes 3 times, correct? So what we get here is take away square root 3 pi divided by 3 times 2, 6. And 1 plus 1, that is what you get, right? So we can now combine these terms, taking 6 as our denominator to write down the answer. So we get 3 minus square root 3 pi plus 6, right? So that is 6 for us. So we have 6 plus 3 is 9. So finally, we get our answer, which is 9 minus square root 3 pi by 6, right? Okay. So we could write this as our final answer for the area, and unit square will be better to write here. Is that clear to you, right? So that is how we are going to solve this particular question. Now I hope with this you understand how to solve a test paper which is something like this. It is section 1 calculator free, where we had questions based on area under the curve, discrete random variable, and logarithms. So look for other links which are on related problems which I'm sharing with you. I hope you understand and appreciate what we have done here. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.